to do. So don't be just playing it continuously and just writing down whatever I'm writing. I want you to do the practice problems when it says to do that as well. Okay, so today we're going to represent functions as graphs. And so basically we're taking what we did in 1.6 when we were having those function rules, those equations, and we did the math. We're going to write the solutions of the input and output ordered pairs. We're going to write those, and then we're going to graph them on a coordinate plane. So then we're going to have a graph. So some of you were already playing around with your graphing calculators when we were doing those 1.6 equations, and it gave you a line on the graph. Well, that's what's going to happen today. We're going to get a line on the graph, and we're just going to graph it on paper for today, but certainly you can check every one of them on your graphing calculator. Before we begin, I want to look at this very first box up here, and I want you to pause the video right now and go through and name as many things as you can, fill in those blanks, as many things as you can possibly do. See how many blanks? A lot of them are vocab words that we've already had. A couple are new. Go ahead and do that, and then when you're ready, come back and unpause the video and see how you did. Okay, so let's go over those. Hopefully you did a good job. We'll see how well. So you can use a graph to represent a function. Okay, that's kind of what I had just discussed with you. And up here it says represent functions as graphs, so you can use a graph to represent a function. In a given table, each ordered pair of input and output values, each corresponding pair, of input and output values forms an ordered pair. I mentioned that at the beginning as well. An ordered pair of numbers can be plotted as a point. So it's a point on the line, and there's infinitely many points on that line. Remember, if I'm talking too fast or something, you pause the video, write down what's important to you, and then resume. The x-coordinate is the input. The y-coordinate is the output. The horizontal axis of the graph is labeled with the input variable, almost always called x, right? And the vertical axis is labeled with the output variable, otherwise known as y. So we're going to go down here to example 1, and we're going to make a graph of the function y equals x plus 1. And since we're making a graph, you can see right here, what are you going to need? You're going to need a ruler. So either you can draw a really nice straight line, or you can use the side of your book, or grab a ruler. So we're going to graph this function, y equals x plus 1. So what was the general form of a linear equation? Do you remember? Y equals, we talked about it last class, mx plus b. Well, there's no number in front of x, so what is the m today? Well, it's like there's a 1 there. That's 1 times x. We're just lazy in math. We don't want to rewrite that whole 1. So we're going to make an input-output table. And we're going to do the domain that they gave us of 1, 2, 3, 4, 5. We're going to plug it into our function rule, and we're going to get our coordinates, just like we did in the last section. So we're multiplying by 1, so really all we're doing is just adding 1 to each input. So now this becomes 2, 3, 4, 5, and 6. Now what we have made is we've actually made sets of ordered pairs. So this is the ordered pair 1, 2, the ordered pair 2, 3, and so on. They're in x, y form. We're going to plot a point for each ordered pair. Plot a point for each ordered pair. So here's my x-axis, here's my y-axis. These are not negative numbers here, that's just the number through the line, through the graph there, the coordinates, or the axes lines. So we're going to go through and we're going to go 1, 2. So we start at the origin at 0, 0. We go right 1 and up 2, 2, 3, 3, 4, 4, 5, and 5, 6. They need to be in a nice straight line. If they're not in a straight line, guess what? You made a little bit of a mistake. So I am grabbing a ruler right now, or you can use your straight edge, and I'm going to connect my points, but I'm also going to extend my line because it goes on forever and ever and ever. So it goes across my whole coordinate plane. Now don't make any teeny weeny graphs. And then I put arrows on the end to prove that it continues. Now if you want to check on your graphing calculator, you can type in y equals x plus 1 on your graphing calculator, and you're going to get this same line on your graphing calculator. Okay? If you didn't get a straight line, one of your points is in the wrong spot, or your table doesn't match mine. So what we're going to do now is we're going to flip over, and I want you to actually go to the third page. So it's actually page 21 down here. Let's get on the screen, page 21. It has a checkpoint at the top, and it asks you to graph this function, 1/3 x plus 1 with a domain of 0, 3, 6, and 9. So pause the video, go ahead and do that, and then come back and see how you did. All right, here's what your graph should look like. So you plugged in your input values, and over here I first want you to notice that 1/3 of a number is the same as dividing the number by 3, right? Half of a number is the same as dividing by 2. So I rewrote it as dividing by 3 because in my mind it was easier than multiplying by 1/3. So then I took my very first input value of 0, I plugged it in, it's 0 divided by 3 is 0, 0 plus 1 is 1. So plugging in 0 spits out a 1. Plugging in 3 spits out a 2, and so on. You have your work to show that. And then I graph it on my coordinate plane. The x values, they had to count by 2s to get it to fit. So you had to do a little estimating there on some of the x values where they were at. It still makes a nice straight line. Alrighty, so let's go back to example 2 now on the previous page. And in this one, we have to write a function rule for the graph. So in 1.6, you were given a table, and you had to write the function rule. Well, now you're given a graph, and you have to write a function rule. Well, here's the easy thing, right? If you're given a graph, and you already know how to write a function rule from a table, why don't you just put it into a table? So that's exactly what we're going to do. We're going to make a table for the graph. How do you find these ordered pairs? You look at their coordinates. So the first one is at 2, 0. 4, and then goes up to 1, 6, 2, careful on how they're counting, 8, 3, and 10, 4. And then you need to find a relationship between the input and the output values. So remember, if it jumps out easy to you, then you're great. If not, then you want to find your y equals mx plus b. You want to find your m. That's the first thing we did. And remember, m was delta y over delta x, the change in the y's over the change in the x's. So this is up by 1. So a 1 goes on top, and these go up by 2. So a 2 goes on the bottom because it's delta y over delta x. So my function rule so far is y equals, I'm going to scooch down here, y equals 1/2 x, and then we're going to test our table and see if it works to give me that y value. The other thing, remember, instead of saying multiplying by a half, I could say y equals x over 2. We just talked about that in the previous problem. So when I take 2 and I plug it in, it's 2 divided by 2, which is 1, and I need a 0. Okay, let's look at the next one before you come to a conclusion. 4 divided by 2 is 2, but I need a 1. So what do I need to do to this guy to get to the right number? You got it. Either subtract 1 or add a negative 1. It's the same thing. So we just wrote the function rule that describes the relationship. All right, a rule for the function is this, or we could say x over 2 minus 1, or even plus negative 1. I'll make it plus negative 1 just to mix it up. And then they asked us to identify the domain and the range for our table up there, okay? So the domain, got our little bird brackets, was 2, 4, 6, 8, and 10. And our range was 0, 1, 2, 3, and 4. All right, let me scooch it up for you. There you go. Okay, so back to the previous page now. That's what we have right down here. You have to write the rule for the function. and then identify the domain and range. So do number 2 first. Remember, you have to start with what? A table. Do number 2, pause the video right now, and then come back when you're done with number 2 and check and see how you did. And then you'll go on to number 3. Okay, let's see how you did. So you made your table. You started with the general form of the linear equation, which is y equals mx plus b, and you found your m. Here's my work for finding m over here on the side. It was delta y over delta x. The change in the y's were 3. The change in the x's were 1. It's 3 over 1, which is 3. That's where this 3 goes right here in for m. Then what you do is you go back and say, all right, does it work? So it's 3 times x. 3 times 1 is 3. Did I get 3 here? No, I have 0. So I have to subtract 3 or add negative 3 to get to 0. So let's check the other guys. 3 times 2 is 6. 6 minus 3, 3. 3 times 3, 9 minus 3, 6. 12 minus 3, 9. And then here's the kicker. Did you remember the end of the directions? You had to write the domain and the range. So see, when I was talking before, if you aren't really looking closely or go back and look at the directions again, you may miss some steps and you would lose points for things that you totally know how to do. Okay, last guy, do number 3, see if you get it right. Here we go. Pause the video. Okay, guys, how'd you do on this one? Y equals 1/2 x plus 5, or you could have had y equals x over 2 plus 5. Okay, so your delta y was 1, your delta x was 2, so m ended up being 1/2, and then what did you have to do to get to the other y values? You had to end up adding 5 to get to the proper y value. And then your domain and your range right there are 2, 4, 6, and 8, and 6, 7, 8, and 9. Okay? All right, nice work. So the last thing you need to do now is go on to the next item on your agenda. Good work, guys.